So this is a question from JEE Advanced 2016 from Laws of Motion. So I'm explaining the question in short that we have a disk, you can see a disk of radius capital R, and there is a groove along the diameter of this disk, right? At t equal to 0, we gently place a block at a radial distance of r by 2 from the axis of rotation. And this system is rotating with a constant angular velocity omega. And the directions are mentioned to you that omega vector is omega k cap. So the upward direction is basically positive z direction. This is the k cap direction. And the x-axis is mentioned along the slot. Y-axis is perpendicular to the slot. You can see the directions over here. X-axis is along the slot, along the groove. The y-axis is perpendicular to the groove, and z-axis is along the axis of rotation. So we need to find the radial distance of the block as a function of time and the net reaction force on the disk on the block, right? In vector format, we need to calculate this. So let us see how we can start this question. So if we look at the top view of this situation, so in top view, you can see that along the groove, we have positive x-axis. Perpendicular to the groove, we have the y direction, and perpendicular to the screen, out of the screen, we will be having a positive z direction. Now this groove, there is a floor on this groove, and there are two vertical walls on this groove. So the weight of the block is actually acting into the screen, right? So weight is into the screen, and this weight will be balanced by the normal force on the block from the ground, right? The floor of the groove will be balancing this normal force. It will be providing a normal reaction which will be out of the screen, and this normal reaction will be balancing the weight. So I can write the value of normal force N1 in vector form as mg is the magnitude and the direction of N1 is k cap. Now, suppose we go to the rotating reference frame. In rotating reference frame, suppose our observer is sitting at the axis of rotation and it is rotating in the same sense as that of the disk with an angular velocity omega. And suppose the block is at a radial distance smaller at some time t. Now, with respect to this rotating reference frame, what will be the forces? One is the inertial forces. Inertial forces means the forces that you see in the ground frame, like mg, normal forces. These forces are our inertial forces. Apart from these real inertial forces, these two terms, 2m into v rotational cross omega, v rotational is the velocity of the block in rotating reference frame. Omega is the angular velocity of the frame. And this term, second term, is our centrifugal force. So suppose at this given instant, the block has certain velocity, let us say v. So this v is the velocity of the block in this rotating reference frame. So there will be a centrifugal force with the value of which can be given as m omega square into r. And this particular force, 2m into v rotational cross omega. So if you realize the direction, v is radially outward along the x direction. Omega vector is out of the screen in the k cap direction, right? So v rotational, this v rotational term is basically v I cap, and this omega vector is basically omega k cap. So the direction of this force, I cap cross k cap, what is the direction of I cap cross k cap? I cap cross k cap will be negative of j cap. So this force will be acting in the negative y direction, the value of which we can write as 2m omega times of v, because the angle between omega vector and v vector is 90 degrees. But this force, which is also called as the Coriolis force, this is basically a Coriolis force. This Coriolis force is acting on the block perpendicular to the wall. Now we know that the block is constrained to move along this groove. It cannot move perpendicular to the wall. So this Coriolis force must be balanced by the normal force on the block from the wall. So there will be another normal force N2, which will be acting from this wall on the block, and it will be in the positive y direction. So the value of N2 we can write, it will be equal to magnitude wise, it will be 2m times of omega into v, because the block is constrained to move along the groove. It cannot move perpendicular to the groove. So this Coriolis force will be balanced by this normal force N2. And the direction of this is along j cap. So the first part is to find the position vector of the block r, the radial distance as a function of time. And the second part is to find the value of this reaction force. So you can see that if we find the value of V as a function of time, then we will be able to find the net reaction force, net normal force. So let us start our equation by writing the Newton's law along the groove. What are the equations along the groove? So you can see that along the groove, there is a force which is the centrifugal force m omega square r. And this force is responsible for providing an acceleration along the groove. So the velocity of the block along the groove will be changing with time, right? So what is the force along the groove? That is m omega square r. And if v is the instantaneous velocity, then I can write this expression as m times of acceleration. Now acceleration I can write as v times of dv by dr, right? So from here you can see that if we rearrange this expression, the m term gets cancelled out. So v times of dv is omega times of or omega square times of r dr. Now if we integrate this expression on both sides, initial condition is mentioned to us that the block was gently kept at small r equal to capital R by 2. So when small r is capital R by 2, the velocity of the block was 0. It was gently placed. At any radial distance small r, suppose the velocity of the block becomes v. So v square by 2 will be equal to omega square by 2 times of small r square minus capital R square by 4. Right? So from here, the two term gets cancelled out. So v as a function of time will be omega times of under root small r square minus capital R square by 4. So this will be the velocity as a function of radial distance small r. Now we know that this velocity, since this velocity is responsible for changing this length radial distance small r, so I can write this term v as dr by dt. So if we write it as dr by dt, then dr divided by under root of small r square minus capital R square by 4, this will be omega times of dt. Now again, if we integrate it on both sides, at t equal to 0, we kept the block at a radial distance r by 2. And at time t, suppose the radial distance is small r. So this RHS term of the integral is simply omega t. What is the LHS term? Now this is a standard integral, that integral of dx divided by under root of x square minus a square. This integral is ln of x plus under root x square minus a square. This is a standard integral. So you can see that this equation is similar to this integral x square minus a square. So the value of a is basically r by 2. So this is r by 2 whole square. Okay, so we can directly use this integral over here. So ln of small r plus under root of small r square minus of r square by 4, and we'll put the limit from r by 2 to small r. This is equal to omega t. Now first we'll put the value of small r. So we'll get ln of small r plus under root small r square minus capital R square by 4 minus of, if you put r by 2 over here, capital R by 2, then you can see that this under root term gets cancelled out. It becomes 0. So we'll be left with only ln of r by 2. This is omega t. Now ln of a minus ln of b. This is of the form of ln of a minus ln of b, which is ln of a by b. So I can write this expression as r plus under root of small r square minus capital R square by 4. And I can take this r by 2 term to the right and e power omega t. We get this expression, right? So let us continue over here. So I can write this as under root of small r square minus capital R square by 4. And I take this small r term to the right. It becomes r by 2 e power of omega t minus small r. Now if we square this equation on both sides, you will get small r square minus capital R square by 4. So this will be r square by 4 e power of 2 omega t plus r square minus of capital R small r e power of omega t. Okay. So r square term gets cancelled out. So capital R into small r e power of omega t. This term will be equal to capital R square by 4 e power of 2 omega t plus r square by 4. Now we need the value of small r. So simply you can divide by this capital R into e power omega t. You divide this complete expression by this factor. So you will be left with r by 4 into e power of omega t plus e power of minus omega t. So this will be the distance, radial distance of the block from the axis of rotation. So a bit mathematical question. This question was a bit mathematical part. So you also need this integral. We need to use this integral. You need to know this integral for solving this question. Now, the reaction values, the normal force. For normal force, we had seen over here that the value of N1 was mg k cap and the value of N2 was 2m omega v j cap. So what are the values of this normal force? You need the value of v for writing the value of N2. So if you need the value of the velocity of the block as a function of time, then simply it is dr by dt. If you differentiate this expression, it will be r omega by 4 times of e power omega t minus of e power minus omega t. Right? We are left with this expression. So what is the value of normal forces? N1 vector, which was simply mg and the direction was k cap. And the value of reaction force M2 was 2m omega v and the direction of this was j cap. Now if you substitute the value of v over here, so 2m omega times of r omega by 4 into e power of omega t minus of e power of minus omega t. So this 4 gets cancelled out, this 2 factor gets cancelled out. We will be left with m r omega square by 2 times of e power omega t minus e power of minus omega t. So this will be the final answer for this question. If you want to write the net normal force, then that is simply n1 vector plus n2 vector. So the value of n1 is mg k cap and the value of n2 will be half of m omega square r e power of omega t minus of e power minus omega t and the direction is j cap. So this will be the expression for the net reaction force.